Hi, thanks for giving me this opportunity to speak with you. And I wish I'd been able to be there in Kampala with you. I've got a project going on behind me here, so I hope the servers don't create too much background noise. I'm Jeff Doyle, data center and automation architect with Alchemy Global Networks. Among other things, I served on the first advisory board for the Network Automation Forum, and among the books I've written, I'm co-author of a book called Network Programmability and Automation Fundamentals. I'm saying all that because that's what I want to speak briefly about today. The Network Automation Forum's Network Automation Framework, or the NAF's NAF, if you don't mind reused acronyms. To put what I'm going to say into context, I want to start by quickly covering some of the drivers for network automation because almost all of us in networking understand the need for and benefits of automation, but it can be a challenge to know how to approach it. I think you're familiar with some or probably all of these. First, network complexity. Modern networks support so many applications with different demands on the network and so many underlying logical layers that trying to run, monitor, and troubleshoot the network node by node from the CLI becomes a formula for missing important details. Instead, we need to begin looking at our infrastructure as a single operational entity, an abstraction of what's actually there. And while the network can flood us with data, all of that data can be important at different times. We need a means to sort through the data and find the facts that are important to us at the moment without losing the data that might be important an hour from now or next week or tomorrow. And consistency in how we collect data, how we change the network, how we observe the network is essential. Time is money. We all understand that operational expense is the largest part of a CIO's budget, always outweighing capital expenditures over time. OpEx means people and how we use our people's time. Operators need to be looking at the big picture and not repeating mundane tasks over and over. That's a hint right there where most people start automating, using scripts, often simple scripts, to perform in seconds what might have taken an operator hours to do from a command line, visiting one node at a time. At the other end of the scale of expertise, our architects should be looking at the network predictively, 1 year, 3 years, maybe 5 years down the road to understand the new demands, application growth, and user changes will place on the network. But too often, your top-level architects are spending most of their time chasing down present problems that are too difficult for the frontline operators to handle. The last and arguably most important driver for automation is getting humans out of the network. I've been quoting this statistic for 15 years or more, depending on the networking question. 60 to 80% of network outages are caused by simple human error. And as of the last study that I read last year, those statistics remain accurate. From simple typing errors at the CLI, and every one of us has our own stories to tell about outages that we've caused by fat-fingering some command, to failure to follow published policies and procedures. I just need to get this done. I'll come back and I'll clean it up later, which, of course, we never do. To even worse, the lack of any policies and procedures in the first place. I can't tell you how many networks I've consulted for, some of them shockingly large and well-known, where at the start of the project I ask for their documented policies and procedures and I'm told there are none. We've meant to get around to that. We've just haven't had the time. Automation can force you to establish policies and procedures and then ensure that your network rigidly conforms to them. The improvement in quality and uptime can be striking. Barriers to automation? Well, there's many, but here's some of the most commonly cited. Automation is complex. I don't know where to start. It takes specialized talent. Do I spend the money to hire talent, or do I spend the money to train up my existing staff in new skills? How do I test solutions before releasing them in my network? Well, digital twinning is expensive, What if I have a multi-vendor network and I need to deal with several operating systems? How much more difficulty does that add? And, of course, what do I mean by automation? How do I define it? Have I asked the right questions, and have I asked enough questions to know how to quantify my results so I can measure my success? Of course, there's cultural resistance. Hey, if automation can do in seconds what took me hours to do from a CLI, how do I justify my job? And up at the top in the boardroom, they want to know what the business case is. Engineers are not always good at expressing why you should spend money on something and how the benefits will outweigh the cost. We engineers are very much not good at projecting financial probabilities. I actually have an entire separate lecture just on that. And finally, simple fear. Am I going to lose control of my network? I hear talk of autonomous networks or self-driving networks. Is that even something I can trust? We've also all heard the very true statement that automating a broken process can just break your network that much faster. And how do we even begin automation? Well, there's 4 basic approaches. The first one people think of most often is do it yourself, build your own. This stems, I think, from where most people first discover the benefits of automation by operators and engineers writing simple Perl or expect or shell scripts or simple Python programs for their own convenience to make their jobs easier. A script that gathers loopback addresses from every router in the network or pushes the new VLAN config to a large set of switches or changes the password on all nodes. We see that convenience and think, maybe automation could be a good thing for me. Characteristics of DIY is that it's OpEx intensive because your staff has to develop and test it, and that development and testing takes time. So you're not going to deploy a DIY solution overnight. It's also OpEx intensive in that it requires ongoing maintenance. You build it, you do the upkeep and upgrades and bug fixes. That's why DIY is usually only done successfully by organizations that already have a substantial DevOps organization. Smaller operators try, but often fail. At the other end of the spectrum is commercial off-the-shelf solutions, aka shrink-wrapped solution or shrink-wrapped automation solutions. This is CapEx intensive because you're paying a vendor for a product. But you can test and deploy the solution pretty fast. The vendor, if they're good, will have most bugs worked out already, and their solution will be proven in other people's networks, unless you're the first customer. Maintenance is easy because if there's a bug, it's the vendor's problem. But you might not get something that fits your network like a glove because the vendor is creating a solution for the requirements and problems of their entire customer base. You may be paying for features you don't want and getting bloated software. But there's a middle road between these two extremes, and that's open source solutions. The best part of open source software is that it's free. Well, sort of. You've still got some operational expenses to adapt it to your network, integrate it with your tooling, and program it to talk to your APIs. You might have licensing expenses if you hire a vendor or a consultancy to perform these integrations and maintain it. The good news is that risk is often low due to a large support community. That's one of the proven positives of any kind of open source software. It's been proven over and over already. Well, at least usually. Someone has to be an early adopter, after all. Another positive is that most open source software is highly customizable, so you can adapt it to your specific requirements and simply not deploy the parts you don't need. Lastly, there's a hybrid approach. See the whole automation landscape as a menu of options. Choose a packaged product for some aspects, build some of your own solutions for others. Use open source for some elements. Expenses go up, certainly, but not as much as the capital outlay of a fully packaged solution or their operational expense, in both money and time, of a fully DIY solution. You develop what you can, buy what you must. This approach nicely fits a gradual, ongoing automation plan where you grab the easy, low-hanging fruit first before moving on to more difficult automation projects. Your staff learns along the way, you gain experience testing your solutions, and you deploy your automation plan in increments, giving your operators time to adapt and learn. So, what is the network automation framework? It's a modular, vendor-neutral reference design for the design, implementation, and refinement of automation solutions. It can apply to any one of the four approaches I defined in the previous slide, and it's meant to provide you with a way of thinking about automation. You can use it to evaluate a vendor's COTS solution, or you can use it to guide your DIY solution, in both cases to ensure completeness. It defines all the key functional building blocks of a solution and is relevant to both new deployments and for evolving solutions. And it's intended to be adaptable to accepted CI/CD methodologies. So let's have a look. This is the architecture. As I said, each of these blocks represents a key automation function. The arrows show how the functions interact with each other and might or might not be present in a specific solution. This just shows the possibilities. For example, the presentation function might or might not interact directly with observability and intent. It might interact only with orchestration, which then represents presentation to the other functions and coordinates information. Similarly, I've shown most arrows to represent two-way functions, which again might or might not be the case. The point is, your potential options in an automation solution are represented here. Note that these functions might also be part of a single automation solution, or they might be individual software elements from different sources that you've tied together. Again, you have options. I'm not going to mention infrastructure again directly because it should be obvious that that's just your physical, maybe logical infrastructure, the nodes making up your network, that you're going, of course, to be automating. It could be a single vendor network, or it could be multiple vendors. It could be just switches and routers, or it could be including security infrastructure, servers, DNS, load balancers, etc. The scope of the automation solution is defined by what you include as infrastructure, what you're going to automate. Now let's look at the individual functions. The collector reads the state of the network and writes it to the observability function. It also defines how to read state. SSH, APIs, GNMI, and so on. The options are there, and the collector knows how to read that state. Observability is a database of network state showing what I have. It includes observational logic and analytics on the data. So, for example, if your automation includes closed-loop analytics, that logic is defined here. Is it a single source of truth? Well, perhaps, although the term has fallen out of favor in some circles. Personally, I still like it. Each node in your network is a source of truth. Every link is a source of truth, but each node has a different perspective on the network and also might represent the same information slightly differently if the NOS is different. The observability database should consolidate all data from the network into a consistent format, hence a single source of truth. That's my opinion anyway. Where observability shows what I have, intent shows what I want, what I expect of my network or the desired state of the network. Intent-based networks remain a popular concept, and in fact, I wrote a whole book on intent-based networking systems. The delta between what I have, observability, and what I want, intent, becomes a potential triggering event for taking action called intent drift. So, for example, if bandwidth utilization on a link goes above a certain defined threshold, or an interface fails, or an eBGP VXLAN configuration cannot be supported, my network no longer meets my expectations, and an alarm might be sent to the presentation function. So, intent can define both configuration and operational expectations and should apply those expectations to an abstraction, a generalized vendor agnostic representation of the physical and logical infrastructure. The executor is the counterpart of the collector. It reads intent data and writes instructions or configuration to the network. Note that translation of generic configurational instructions into vendor-specific NOS commands should be a part of the executor, but depending on the implementation, this could also happen somewhere in the intent function. Personally, I think it should be a part of the executor. Orchestration interacts directly with observability and intent and ties simple automation tasks into a complex workflow. It can include things like scheduling, event-driven actions, should contain compensating actions such as a rollback for unexpected results, and a nice to have in an orchestrator is a dry run function in which you can execute and validate a workflow without actually pushing anything through the executor to the infrastructure. Orchestration can also be responsible for pulling data from the presentation function, pulling data for the presentation function. I think I mentioned it earlier that while I've shown arrows between orchestrator and the collector and executor, in most implementations, it's unlikely that those arrows would exist. It also doesn't interact directly with the infrastructure. Instead, it coordinates interaction between observability, intent, and presentation. If it interacts at all with the collector and executor, it's likely to become some sort of validation, monitoring, or scheduling function. And finally, we have the presentation function, the interface between the user and the automation system. Lots of automation vendors like to talk about providing a single pane of glass or a common point through which you interact with and gain insights into your network. A single window through which you view your network, if you want to think of it that way. It's a good concept, but in reality, presentation is likely to include many windows into the network. Dashboards, probably many dashboards showing everything from topologies to warnings and alarms to state to in-depth telemetry and analysis. A graphical user interface, or lots of graphical user interfaces, of course, because that's how users like to interact. CLI tools that mimic a terminal session directly on a network node when you need that, but because you're doing it through automation from the presentation, you can add context and validators to ensure your operators are not doing something that will break your network or violate intent. API gateways that allow integration with other network tools, and increasingly, AI interfaces that allow you to do things like having plain language queries, or more advanced, AI analysis of your telemetry in your network. Presentation can include much more than these, but these are just examples that I can think of. Basically, any way a user interacts with the automation system and hence interacts with the infrastructure happens at the presentation function. And that's the network automation framework. But this isn't a finished project. Rather, it's a work in progress. In fact, I consulted the NAF documentation in making these slides and found that it's been updated just in the 2 weeks since the last time I looked at it. So the network automation function is still evolving the framework. The framework itself is unlikely to change, but documentation, underlying details, and procedures on using it will. User feedback and participation, your user feedback and participation, is very much welcomed and encouraged by the Network Automation Forum. Documentation is continuously updated on the NAF website and in GitHub. I've provided a link to the documentation here, but you really don't need to remember it. Just Google the Network Automation Forum and go to their website, and you can easily find the framework documentation under Resources. Thank you again for your time. And if you have any questions or want to learn more, you can reach me at jdoyle@agn.tech, or you can talk to my friend and colleague Eman, who is there with you right now. Thank you so much.